So we are going to kick it off with Sushim.
Okay. So we came up with this project idea after reflecting on the recent crime that has been going on in the US and worldwide. We created a product that analyzes pictures for dangers and threats such as knives, guns, and other weapons in public areas. Our original goal was to use CCTV footage to sense weapons with the ability to detect if a person was holding the weapon or not. Ultimately, with the 3 weeks that we had to create this model, we were a little limited on what we could do. The final product is capable of detecting 6 individually different classes from whatever image the user may have inputted, and recognition of the 6 classes can be a little spotty. For the most part, our accuracy is satisfactory and we do produce positive results.
With the first iteration of training the model, we started with a data set of 940 images with a total of 7 classes: holstered and unholstered handguns, explosives, knife in and out of hand, and then rifle off and on person. We then augmented the data set with the flip, blur, and brightness filters and ran the data set through the model. There were some problems with this iteration, however, such as knives were constantly being detected as guns due to uneven sorting between the testing, validation, and training sets, and other inaccuracies. So in the second iteration, we added an additional 168 images to the data set in order for the classes to be better represented in the data set, and then we readjusted the bounding boxes of the images. However, it was still having an issue differentiating between knives and rifles due to all 200 knife images only being the validation and testing sets and not the training set. So in the fourth iteration, we kept the same images. However, we combined the knife in and out of hand classes into the knife class. And then we redistributed the knife images between the sets in order for the model to be able to train for knife, as well as added a noise augmentation to the data set as a whole. With these changes, there was a huge improvement in the results of the model. However, there was still a lack of null images within the data set. So in the fifth iteration, we added an additional 210 images for a total of 1,318 images, including more knives and null images, overall showing a huge improvement in every aspect, however, not without its flaws. So in the sixth iteration, the latest one in our website, we added 100 images for each class in order to improve the accuracy of the model, and this one showed the best results out of the 6.
So now I'm going to demo our project. So if you come to our website and we'll choose a file, let's start with a handgun, for example. So the model automatically detects that this is a handgun. And a big part of this that we wanted to do was we wanted it to detect whether the gun was a threat or whether it wasn't a threat. So we have 2 different classes for handguns and for rifles, whether they are on a person or holstered, or like the person is like using them and they're like unholstered. So you can see this right here. If we put an image of a holstered handgun, it detects it with 72% confidence that it's not a threat. For example, our knife class, it detects a knife, 67% confidence, which is awesome. And right here, you can see another example. It detects that the rifle is on a person and that person might be a threat. And then, for example, in this image, it detects a bunch of rifles and it notices that they are not on a person and therefore likely not a threat. Also, just to show it off, if you have just a random image of people, it won't find anything. Yeah, and now I will hand it over to Asong, who will be talking about the flaws.
Yep. So as previously seen, our model is able to predict images in a very accurate fashion. However, as expected with the model only trained for 3 weeks, there are obviously some misidentifications and stuff. So, for example, in this image, our handguns are not identified, and this is due to a large skew in our data set, as unholstered handguns were severely underrepresented in our 1,000 so images. In the second image, this shows it sums up our model pretty perfectly, as rifles off person were overrepresented in our data set, and that's why I was able to detect a little small lift off to the side. However, the big rifle in the middle on the person was a class that was severely underrepresented in our data set, and therefore the model was not accurate in its prediction. Again, this displays the underrepresentation of rifles of our class rifles on person in our data set. And then finally, one of our largest issues in our data set was the lack of representations in knives. And so you can see it identifies the banana as knives. And these problems could have been fixed by making the data set a little bit more balanced, and of course having a bit more time to train on. So I will now pass it over to Diego to talk about our front end and our website.
All right. So the front end of our website, which interacts with our model, was created with a Bootstrap template we got from startbootstrap.com. We then edited the template to meet our specifications and overall modifications that we needed to make. We had a number of various problems with the CSS. It seemed that every time we constructed or fixed something, another element broke. So we had our minds boggled and overloaded with the amount of debugging the simple process of editing this template, and we were getting pretty strained. However, after about a day of debugging and correcting other inconsistencies, we were finally ready to implement our model into our website. We started this off by beginning to learn about how to use Flask, a Python framework that allows Python elements to interface with the website's front end. This was also another growing pain for us in the aspect that having Flask interact with our front end took even more debugging. But eventually, we managed to finally have our front end and our model connect. Now we just had to do like a bunch of refinement. So we discovered that there were still underlying issues with our CSS, such as our part of the website that showcases photos and descriptions of the team. They were constantly breaking, and one notable issue was that like our photos have these rounded edges, but well, yeah, it was intended to give it a more elegant look, but we found that whenever we applied this to the CSS, it applied to every photo. So it kind of messed around with the look. So that was just one among a bunch of others. However, we did in time correct these errors, and we were finally ready to send our products off.
Okay, so our product reflects the short 3 weeks we had, but our team had bigger plans than just detecting things in images. As stated in the beginning of our presentation, we were planning to use CCTV footage. Our original idea expanded to what could be a full-blown product. It was to detect whether a situation was hostile or not using live footage and audio detection. It was also supposed to be able to tell the difference between a person threatening others with a knife and someone cutting up some steak. We even had an idea where it'd send out alerts, whether that be to everyone in the area, the owner, or police. Of course, there's always things that can go wrong. There were chances of the perpetrator being alerted as well, misidentifications which would lead to falsely calling the authorities, and weapons of cops being identified as threats. In conclusion, there were a lot of things we got done in 3 weeks. However, to create the product we envisioned, you'd need AI, true artificial intelligence that can understand what we do about a situation. And maybe we can achieve that. It just takes people like us putting our minds together like we did here in AI Camp 2022.